This video is about test for cations. It is prepared to make it easier for the students how to identify cations according to Cambridge IGCSE syllabus from the colors of the solutions, colors of the compounds, and the tests and their results. In Cambridge IGCSE, students are required to know 8 cations, how to test for each of these 8 cations. 3 of these cations are non-transition metal cations, zinc, aluminium and calcium ions, in addition to ammonium ion, which is also can be considered as non-transition cation, but we cannot say non-transition metal because it is not a metal. Also we have 4 transition metals ions: chromium 3, iron 2, iron 3 and copper 2. Non-transition metals ions. These ions are zinc, aluminium, calcium, and we have also the polyatomic ion, ammonium ion. We have to keep in our mind before we start solving questions related to tests for ions, gases and so on, that the solutions of non-transition metal ions are colorless and their compounds are white, because in many questions at the beginning of the question they might give you the color of the compound or the color of the solution and ask you what can you conclude about this compound. If the compound is white or its solution is colorless, then the conclusion will be it doesn't contain transition metals ions, because transition metals ion solutions are colored. As you see here, chromium 3 is green, iron 2 is a green solution, Fe3 plus solution is yellow, and Cu2 plus solution is blue. Because all non-transition metals ions are colorless, we cannot identify any of these ions by looking. Also for transition metals ions, in many cases it will not be clear for us from the color which ion is this, especially like for chromium and iron 2 ions. So we go through chemical test, and in chemical test for cations they ask us to identify the reagents that can be used. 2 reagents are used. One of them is a strong alkali such as NaOH, KOH, lithium hydroxide, cesium hydroxide, rubidium hydroxide, barium hydroxide, and another test will be using weak alkali like ammonia, ammonium hydroxide, methylamine and so on. The results of these 2 tests will help us identify the cation present. For ammonium ion, we test for it using NaOH and heat only, or we can use any of the strong alkali, KOH, lithium hydroxide and so on. With the test for zinc 2 plus ion, we will do the test with NaOH, and we will repeat the same test with ammonia and see if there is any difference, and we will note down the observations. First we add 2 cm³ of zinc 2 ion solution to a test tube. Then we add drops of strong alkali NaOH or white precipitate forms. Then we continue adding excess NaOH, precipitate dissolves. So with zinc, with excess NaOH, the precipitate dissolves. We repeat the same test with ammonia. We place 2 cm³ of zinc as before in the test tube. Then we add drops of ammonia and we observe also white precipitate forms. We continue with excess ammonia or precipitate dissolves. So This is the test and the result for zinc with both NaOH and NH3 with drops of each forms white precipitate, with excess forms the precipitate. We will do the test for aluminium ion. We will do the same using NaOH 2 cm³ in the test tube. Then we add drops of NaOH, white precipitate forms. We continue with excess NaOH, precipitate dissolves. We will repeat with ammonia to see if there is any difference from that of zinc. We add drops of ammonia, also white precipitate forms. Then we add excess of ammonia, precipitate doesn't dissolve. So the test of aluminium differs from the test of zinc in that with excess ammonia the precipitate doesn't dissolve. Go to the test for calcium ions. We do the same. We place 2 cm³ of calcium in the test tube. Then we add drops of NH3 for calcium. We start with NH3, no precipitate forms with the drops. We add excess NH3, also no precipitate. We repeat the same test with NaOH. Drops of NaOH to 2 cm³ of calcium ion solution, white precipitate forms. Then we add excess NaOH, precipitate doesn't dissolve. As a conclusion, we can write as follows. We add NaOH test for chromium ion. We do the same. We place 2 cm³ of chromium in a test tube. Then we add drops of NaOH and we observe green precipitate forms with the chromium. It settles down to the bottom. Then we add drops of excess of NaOH, precipitate dissolves, forming green solution. We repeat the same with ammonia. We add drops of ammonia to 2 cm³ of chromium solution, green precipitate formed also, but this time it is gray-green precipitate. We continue adding excess ammonia, precipitate doesn't dissolve. So we noted down that chromium gives green precipitate with NaOH and gray-green precipitate with the drops of ammonia, and this precipitate dissolves with excess NaOH. Then we do the test for Fe2 plus ions. We place 2 cm³ of Fe2 plus. Then we add drops of strong alkali to the Fe2 plus, green precipitate form, dirty green precipitate. We add excess NaOH to the formed precipitate. PPT doesn't dissolve, unlike with the chromium. With the chromium, the green precipitate dissolved with excess NaOH. Then we do the same with ammonia. We add drops of ammonia, also dirty green precipitate formed and settles to the bottom. Then we add excess ammonia, precipitate doesn't dissolve. So we can distinguish between chromium and Fe2 plus ion from the test using NaOH, because chromium precipitate dissolves with excess NaOH, while iron 2 plus green precipitate doesn't dissolve with excess NaOH. For iron 3 ions now, we do the same. 2 cm³. Then we add drops of NaOH and observe red-brown precipitate formed with iron 3 ions and drops of NaOH. We add more NaOH excess, precipitate doesn't dissolve. We repeat the same test using drops of ammonia with Fe3+, also red-brown precipitate forms. Then we add excess ammonia, or we can use any weak alkali, precipitate doesn't dissolve. For copper 2 ions, we add 2 cm³ of copper 2 ions to the test tube. Then we add drops of NaOH, blue precipitate forms. Then we add excess NaOH, precipitate doesn't dissolve. We repeat the same with ammonia. Also blue precipitate formed. If we add more ammonia, the precipitate dissolves, forming deep blue solution. This is the test for copper 2 ions. For ammonium ion, the last slide here shows summary of all tests and their results. Ammonium ion with sodium hydroxide, when it is warmed, it produces a gas that turns damp red litmus paper blue, which is ammonia. Calcium white precipitate insoluble in excess sodium hydroxide, and no precipitate with ammonia. Sometimes very slight white precipitate might appear. With aluminium with sodium hydroxide, white precipitate soluble. With ammonia, this white precipitate is insoluble. Zinc, white precipitate soluble in both ammonia and sodium hydroxide. Chromium 3 gives green precipitate soluble in excess sodium hydroxide. Gray-green precipitate with ammonia insoluble in excess ammonia. Copper 2 ions give light blue precipitate insoluble in excess sodium hydroxide. Light blue precipitate with ammonia with drops of ammonia, and this precipitate dissolves with excess ammonia, producing dark blue solution. Iron 2 gives green precipitate insoluble with both sodium hydroxide and ammonia, same result. Iron 3 gives red-brown precipitate insoluble in excess with both sodium hydroxide and ammonia.